Hello, good morning. Welcome everyone to Examining Carbon Capture through a Public Health and Environmental Justice Lens. On behalf of Physicians for Social Responsibility and the Science and Environmental, Science and Environmental Health Network, I'm really glad that you're here with us. And I hope many of you are enjoying as perfect a spring morning where you are as where I am in Maryland outside of Washington. You're about to hear a really outstanding presentation, a series of presentations on a vitally important issue, carbon capture and sequestration. It's an issue that could have a bearing on our nation's use of fossil fuels, on global greenhouse gas levels, and on our future on this planet. I'm Barbara Gottlieb. I'm the Director for Environment and Health at Physicians for Social Responsibility, PSR. We're a national organization of physicians and other health professionals working nationwide to address the greatest threats to human health and survival: nuclear weapons, and climate change. Because of our focus on climate change, carbon capture and sequestration is an issue of real concern to us and one that we have spoken out on in the past. So we're really delighted to be participating in this presentation today. There are some nature-based ways that carbon can be sequestered, through forestry, for example, through changes in how we do agriculture. But as it is being promoted today in many quarters, carbon capture and sequestration is a techno fix that is rife with flawed assumptions, potentially huge financial expenses, and serious threats to health and the climate. That's what we're going to learn about today, and we have a wonderful lineup of expert speakers. I'm going to pass the microphone to Carolyn Raffensperger of the Science Environmental Health Network, who is co-sponsoring this event. But first, just a few quick housekeeping details. First, you will be muted during this presentation, but we want to hear from you. We're reserving a quarter of an hour after the presentations for a question and answer. To send us your questions, please use the Q&A function. Do not use the chat. We will not be monitoring the chat. So if you want us to see your question, post it in the Q&A function that you should be able to see at the bottom of your screen. And we will answer as many of your questions as time allows. Also, this webinar is being recorded, and we will send a link to that recording to everyone who has registered. We'll also be sending you a link to a PSR webpage where you'll be able to access a wealth of valuable written materials prepared by PSR and SEHN for your use. So I hope you'll draw on this presentation and on those materials as you take action to help us block carbon capture and sequestration. So it's my pleasure now to pass the microphone to Carolyn Raffensperger, Executive Director of the Science and Environmental Health Network. Carolyn?
Thank you, Barb. As Barb mentioned, I'm the Executive Director of the Science and Environmental Health Network, and you can go look up our organization on the web at www.sehn.org. We do several different things. And most notably, we provide technical science and legal and science technical information to grassroots groups who are trying to protect their homes, their communities, water, land. And we have a number of scientists and lawyers on staff. But today, we're going to be sharing with you some of that, the knowledge that we have gained in our exploration of carbon capture and storage. And I'm going to tell you a little bit more about it, expanding on what Barb gave earlier. And the first is that there are three major components of carbon capture and storage, all of which have major public health implications. The carbon capture part of it is where they put a major mechanical device on top of some piece of equipment, the ethanol factories or refineries or other things, to capture CO2 and then to transport that CO2 once it's been pressurized into a supercritical liquid and move it somewhere to a place where it can either be sequestered deep below the ground surface or used for enhanced oil recovery. Each one of those three elements, the carbon capture, the pipelines, and then, or other forms of transportation, but primarily pipelines, and then the sequestration or enhanced oil recovery, all have unique public health dimensions. The overarching one is, of course, the nature of CO2 And that carries over through all three of the elements of carbon capture and sequestration. So we'll hear more about carbon capture and the pipelines and sequestration in this presentation. But I want to highlight that it implicates the public health system itself. And there are things that you will not hear in standard conversations about carbon capture and storage. You'll hear a lot about CO2 being an asphyxiant or a toxicant, or that in carbon capture, you actually create additional pollutants from, say, the refinery. But you will not hear things like during the construction of the pipelines, you're at a higher risk for sex trafficking. We know that pipeline construction, for instance, increases sex trafficking. It's been written into things like the Minnesota Environmental Impact Statement for other pipelines like Enbridge Line 3. And so we know that even the state of Minnesota predicted that they would have increased sex trafficking for those pipelines. And in fact, they did. They had to make many arrests for sex trafficking associated with that pipeline. It's not something that the regulators usually consider, but in a public health frame, we want to assess all of the dangers and the risks and the public health implications of carbon capture and sequestration. So you're going to hear a lot about the larger systemic dimensions of public health implications of carbon capture and sequestration in today's presentation. And each one of our speakers will highlight various elements of that. And so our first speaker is my friend and colleague, Ted Schettler, who is a physician with an MPH from Harvard. He's the science director of the Science and Environmental Health Network, and he's going to give us an overview of CO2 toxicity and concentrated CO2 and the co-pollutants at capture sites. And I'm going to turn it over to you, Ted.
Thanks very much, Carolyn. And thank you all for joining us this morning. Julia is going to put up some slides. And as Carolyn has mentioned, I'm going to talk about some of the hazards and risks associated with concentrated CO2 and also co-pollutants at CO2 capture sites. So if you could go to the next slide, I just want to point out that on the capture side of this, I'm going to be talking about CO2 capture, particularly at ethanol plants and post-combustion fossil fuel energy facilities. And I will not this morning be talking about either direct air capture of carbon dioxide from the ambient air or from pre-combustion fossil fuel energy facilities. Next slide, please, Julia. So a few comments about carbon dioxide itself. As you know, this is it's a product. CO2 is naturally produced in our metabolic processes, and then it's transported through the blood where it's excreted by exhalations from the lungs or through urinary excretion of bicarbonate. And the levels of CO2 in the blood normally are very tightly regulated by normal physiologic processes, because if the CO2 levels in the blood begin to rise, it causes the blood to acidify, called acidosis. This is a reaction that occurs when carbon dioxide encounters water. So CO2 plus water yields carbonic acid. So that's the sort of the normal circumstances of CO2 in our physiology. But now let's consider CO2 as a gas that we might encounter coming from a concentrated source. CO2 is colorless and odorless, so that if any people who encounter CO2 are unlikely to be aware of it until they begin to develop troubling and dangerous symptoms. It's heavier than air, so it tends to collect near the ground. It flows downhill. And in so doing, it displaces air. And for that reason, when people are exposed to elevated levels of CO2 in the ambient air, it acts as an asphyxiant. But in addition to that, it has toxic properties that are largely related to its being able to cause acidosis in the blood. And if we look at this chart that's on the screen here, you can see that as the levels start to go up in the air that we're breathing, we begin to see some symptoms. So at 2%, our breathing increases, and that occurs very rapidly. And then when it goes up to 4% concentration, the increase in breathing rate becomes really distressing. And now we begin to see the development of respiratory acidosis. And I'd point out that at just 4% concentration, the National Institute for Occupational Safety and Health considers this concentration to be immediately dangerous to life and health, not only because of the acidosis, but because it can cause confusion, and people who are exposed at that level may not be able to recognize what's going on and get themselves to safety. And then as the concentrations rise to between 5 and 10%, the symptoms really get much more distressing and can lead to unconsciousness within a few minutes. And more than 10% can lead to death within 10 minutes, and above that to death within a minute. So this is a very rapidly accelerating set of symptoms and outcomes. Next slide, please, Julia. So let me now turn to carbon capture and what's required in order to do that, whether it's at an ethanol factory or whether it's on some other piece of industrial or some other industrial facility. The carbon dioxide that's captured in these places needs to be compressed into a liquid or supercritical form for transport, and this requires energy. And it's excess energy above and beyond what, for example, a power plant might be producing for whatever its industrial use is, so that a power plant with CO2 capture attached to it requires somewhere between 12 and 40% more energy per kilowatt hour than a plant without a CO2 capture. And of course, this means then that there will be increased emissions that will be associated with this increased energy demand. The CO2 will be reduced because it's being captured, but all the other emissions will be increased. And in addition, there will be increased upstream environmental and health impacts from the extraction, transport of additional fuel required. Next slide, please. So what are these extra emissions of hazardous air pollutants that come from this excess energy demand? If it's a gas-fired power plant that's providing the excess energy, there will be increased emissions of nitrogen or oxides of nitrogen, methane, which are both ozone precursors, and nitrogen dioxide also contributes to particulate matter formation. If it's a coal-fired power plant that is providing this extra energy, there will be additional contaminants, including sulfur dioxide, mercury, other metals, and lots more particulates. And these impacts will largely be felt in local communities where these power plants are being operated. Well, what are the health effects associated with these emissions? Nitrogen dioxide, for example, causes airway inflammation, decreased lung function, asthma exacerbation. Ozone causes cough, wheeze, asthma exacerbations, asthma onset in people who didn't previously have it, and it aggravates other respiratory diseases. And particulate air pollution, particularly the particulates that are 2.5 microns in diameter and smaller, are clearly associated with a range of health effects, including premature mortality, cardiovascular disease, bronchitis, cognitive decline and dementia, preterm birth, low birth weight, and birth defects. These health effects in communities where the emissions increase will largely be felt in the places where the excess energy is being generated. Next slide, please. Now let's turn briefly to a few comments about CO2 capture from corn fermentation to make ethanol. This is a fairly pure carbon dioxide stream that comes from the fermentation of corn. It has the possibility of having low levels of other contaminants, but compared to this exhaust stream from a power plant, it's much more pure CO2. However, it's wet when it is generated from the fermentation process, and it needs to be dried or dehydrated before it is compressed for transport through a pipe. The reason for that is because carbon dioxide and water form carbonic acid, which is highly corrosive in carbon steel pipelines. Triethylene glycol is the agent that is most commonly used for drying CO2 that comes from ethanol produced from corn fermentation, although there are some other compounds that are sometimes used. The exhaust stream of CO2 is bubbled through a container of triethylene glycol, from which the CO2 is vented, but then this needs to be distilled to get the water out of the solvent. And that requires energy. So that's the excess energy that's required in a CO2 or an ethanol production plant. Next slide, please. And if we look now at CO2 capture from coal or gas combustion, this is a much more complex flue gas stream that contains not only CO2, but a number of other constituents depending on the fuel, whether it's a gas a power plant or a coal-fired power plant. The CO2 must be separated and then collected and separated from these other constituents in order to be collected and compressed. And that's typically done by using the most common mechanisms are using solvents called ethanolamines, which is really a family of chemicals. And I've listed here, for example, monoethanolamine or MEA is commonly used, but diethylethanolamine is also used, and so on. Sometimes there are mixtures of these solvents that are used. The toxicity of these solvents varies, but includes asthmagens, skin irritants, and strong eye irritants. But what happens is then the ethanolamine solvent that is now gathered the carbon dioxide, it converts the carbon dioxide into a carbonate salt. This then is transferred to a stripper where heat is applied in order to separate the carbon dioxide from the solvent so that the solvent can be recycled. The CO2 is then captured. But in this process of heating the solvent CO2 mixture, the solvent is partially degraded. And when that happens, it must be at some point captured as a hazardous waste. And I've given you here just an estimate of the amount of waste associated with capturing CO2. On a typical power plant, it might capture 1 million metric tons of CO2 annually. Between 300 and 3,000 metric tons of this amine waste is generated. And it needs to be handled as a hazardous waste because it contains a variety of contaminants, including chemicals that are associated with sensitization, irritation, as well as carcinogens that are in this mix of contaminants. They need to be handled as a hazardous waste. They're typically disposed of either in a landfill, sometimes incinerated. There are attempts to biodegrade them, but that turns out to be a slow process and is still in development. So there are these hazardous wastes associated with this process that we need to keep in mind as we think about further deploying these technologies. And with that, I will stop, Carolyn. Thank you very much. You'll need to unmute, Carolyn.
Thank you, Ted. I wanted to prevent the telephone from ringing. I want to pass the mic to Sandra Steingraber, who is a biologist and the senior scientist with the Science and Environmental Health Network. And she's going to speak about toxic elements and risks baked into our all along the CCS life cycle. Sandra.
Thank you, Carolyn. Always an honor to speak after Dr. Schettler. My task today is to explore with you the toxic elements of carbon capture and storage throughout the whole life cycle, the various risks and harms it creates along the way. And I'm going to begin that story after it comes out of the smokestack, because you just heard the first half of that story very eloquently described, and begin by with the point at which the carbon dioxide is transferred into a pipeline and its subsequent journey to a subterranean vault, which is to say not a sealed container of any kind, but just some rocks underground. So this is a travel story, and to narrate it, I'm going to be using my voice rather than slides, and let you know that in a few weeks, Concerned Health Professionals of New York, which is a project within Science and Environmental Health Network, will be releasing the 8th edition of the Compendium of Scientific, Medical, and Media Findings Demonstrating the Risks and Harms of Fracking. This is the 7th edition, and the 8th edition contains an independent unit on carbon capture and storage as it intersects with the process of fracking. So very soon you'll have a detailed, fully referenced discussion of my words that are drawn from that document today. So to begin, I want to actually back way up and consider the space that carbon dioxide occupies in the popular and scientific imagination. And I'll start with an evolutionary point of view. From the point of view of evolution of life on Earth, carbon dioxide plays a heroic role. It's a molecule whose atoms are held together with bonds oriented in such a way that when struck by thermal radiation, a CO2 molecule will begin to vibrate, and that is how it traps heat in the upper atmosphere. When thermal radiation from the sun bounces off the Earth's surface and tries to radiate back into outer space, a CO2 molecule that occupies that atmosphere starts doing its little vibrating dance, and so prevents heat from leaving. And that's why it can get completely dark at night with no light energy at all, while the sun is on the other side of our planet, but it doesn't get completely cold, right? The nighttime temperatures don't plunge to minus 400 degrees every time the sun sets, and our oceans don't turn into skating rinks, our blood plasma doesn't freeze to ice, thanks to CO2, which forms an atmospheric blanket that has made life on Earth possible. And from an ecological point of view, carbon dioxide is a valuable player because it allows plants and animals to coexist in mutual interdependency, plants using photosynthesis to turn that carbon dioxide into themselves, breathing out oxygen as a waste product, and all of us non-photosynthesizers breathing in the oxygen that plants make for us, using it to run our Krebs cycles to extract calories of energy out of our food, and thus exhaling carbon dioxide as a waste product, which is then absorbed by plants. Now, from a climate point of view, CO2 is a villain, rightfully. By burning immense amounts of fossil fuels during the past century and a half, we've loaded up the atmosphere with so much excess carbon that its heat trapping abilities now threaten to capsize our whole boat, and we're now in the midst of a very dire climate crisis. I want to touch on another property of CO2 that Dr. Schettler talked about, its lesser known superpower, which is that it converts to carbonic acid in the presence of water. And that's the second plot line in the climate crisis that is responsible for the phenomenon of ocean acidification. So we're dissolving the skeletons of coral reefs and basically anything with a calcium carbonate shell, including zooplankton, the basis of the whole food chain in the ocean. We're even dissolving now the skins of sharks because the oceans have become 30% more acid by the outcome of the fact that CO2 in the atmosphere, all the excess CO2 is being absorbed by the ocean and turning into carbonic acid. And that is a whole separate crisis in and of itself. We're literally dissolving the inhabitants of the seas. And that acidification property is what inside of us is called acidosis that you just heard about. Now, from a popular public health point of view, CO2, I would argue, enjoys a kind of benign neutral reputation. Those of us who deal with toxic chemicals don't think about CO2 like in the same way we think about lead or arsenic or DDT or benzene. We understand CO2 as something that we don't really fear. In fact, it's natural. We breathe in a pint of atmosphere with every breath. 2 cups of atmosphere goes inside, deep inside of our chest walls. We absorb the oxygen and we exhale, right, the CO2. And exhalation is thought of as a relaxing thing to do. It's part of yoga and meditation. We expel CO2. We don't know anybody who died of CO2 poisoning, so that when we as public health professionals worry about air pollution causing asthma or heart attacks or strokes or lung cancer and all the things you just heard from Ted, we think about polycyclic aromatic hydrocarbons, ozone, fine particles, VOCs. We don't think so much of carbon dioxide. So that's what I need to revise to, as we talk about the health risks faced by frontline communities, where the CO2 pipelines are going to be built and where the CO2 is going to be shoved in the ground. In fact, as you've just heard, and I want to emphasize this again, CO2 is so acutely toxic to our biology as living organisms that we have evolved elaborate internal mechanisms to monitor it, to tightly control it, and to expel it from our bodies. And we don't worry about CO2 poisoning precisely because all organisms are so good at getting rid of it. And we have to be good at it. Because of that phenomenon of acidification, acidosis, if CO2 builds up even momentarily inside of our bodies, we will start to dissolve. So we have these elaborate redundant systems to prevent that outcome, as documented by Dr. Schettler. We have chemoreceptors in the medulla of our brain. We have them in the aorta near the heart. We have them in the carotid arteries in our necks, all monitoring CO2 levels in our blood. And we will immediately change our breathing rate, starting to pant or sigh if we need to expel some CO2. In addition, our kidneys are maintaining the pH by regulating bicarbonate, which is part of that equation. And like all living organisms, we have enzymes, namely carbonic anhydrase, that work elegantly without any higher level thinking required on our part to tightly and super tightly regulate CO2 inside our bodies. Okay, all this matters because when CO2 is captured from a smokestack with this machinery called carbon capture and storage, cooled into a supercritical liquid, pressurized to 1,000 pounds per square inch, and sent through pipelines that bisect people's communities and route to its burial, its inherent ability to dissolve things gets even more powerful. If there's any moisture inside those pipelines, they will corrode as the CO2 turns into carbonic acid. So these pipelines need to be lined with chrome. They have to be much higher quality than the kind of pipelines that are used to ferry CO2, to ferry gas and oil around. So one risk is exposing people who live near these pipelines in the community to breaches and accidents of those pipelines, to acutely high levels of CO2 that do not exist naturally, at levels that will override their otherwise innate, elegant biological abilities to get rid of CO2 out of their bodies. CO2 is heavier than air. It will displace oxygen. So before it starts to dissolve the inside our bodies, it will act as an asphyxiant. As you heard, it also causes intoxication, making us delirious and unable to try to escape. Importantly, also, because CO2 during an accident with a pipeline displaces oxygen, oxygen are also needed for internal combustion vehicles to work. So rescue vehicles, ambulances, or people's own cars as they try to evacuate will sputter to a stop, leaving them as kind of in a kind of haze, a zombie-like situation behind a car that won't even go. We know that this can actually happen in real life because it has. In February 2020, a carbon dioxide pipeline ruptured in Sartaria, Mississippi, hospitalizing 49 people. And many were unable to escape precisely because their vehicles wouldn't work. Rescue was made difficult, and many victims continue to suffer long-lasting health problems. I want to say that the carbon dioxide within this particular pipeline was also contaminated with hydrogen sulfide gas. Now, once the carbon dioxide waste is buried in geological formations, its long-term behavior is unknown. Under Section 45Q of the Internal Revenue Code, companies claiming tax credits for its capture do not need to ensure that carbon dioxide stays put in the ground, and there are reasons to think it may not. And that has, of course, consequences for the climate crisis, but I want to close here by pointing out that it also has consequences for drinking water. Because some fraction of that carbon dioxide may begin to mineralize. However, in the presence of moisture, remember, it turns into carbonic acid, and it can react chemically with underground strata, leaching heavy metals, dissolving rock and cement. If fissures or cap rocks or abandoned wells offer pathways to leakage, liquid carbon dioxide waste can potentially acidify and permanently contaminate underground aquifers, poisoning drinking water for millions of people. So I'm going to wrap this up by saying that for communities who live near pipelines, the danger is acute exposure to CO2, which is a powerful cellular poison at levels that we are normally not exposed to. And we do not really have good protocols for how to help those folks in the public health literature. For communities living in places where carbon dioxide is buried in the earth, the risk is to drinking water. I also have some information to share with you, but I'll do it in the Q&A about the indirect health effects of carbon dioxide when it is used for extracting more oil out of the ground, a phenomenon called enhanced oil recovery, which is actually how most of the captured CO2 is used. It's not permanently buried in the ground. It's actually used to help the oil industry get oil that otherwise would have stayed in the earth out of the ground. And of course, that has consequences for all of us in the form of climate change. Details to come if you want to know more about that. Back to you, Carolyn.
Thank you, Sandra. And I'm turning it over to Maureen McCue, who is the president of PSR Iowa. She has both a PhD and an MD and is going to talk about the kinds of the implications for rural health systems. So glad to have you, Maureen.
Thank you, Carolyn. I'm almost breathless after listening to both Sandra and Ted. I'm going to switch gears. I'm going to draw my comments from my experiences as a longtime resident, a very long-time resident of rural Iowa, as well as a rural health physician and health resources scarcity area in Southern Illinois, and abroad in my global health work. And then through years of participating on county boards of public health. The Iowa and nearby Midwestern CCS projects are the first link in a really complex network of proposed projects that are going to disturb and threaten much of rural land across the US. And why am I concerned? Besides all of the things we've just heard, like all parts of the country, rural areas face increasingly frequent and more extreme weather events as climate change unfolds. We've seen our share of derechos, floods, and droughts, all of which make our land unstable, contributing to some fear about rupture of these pipelines. And installing thousands of miles, really thousands of miles of CO2 pipelines not only adds to our unfolding climate threats, as we've already heard, but they uniquely and particularly threaten the health and well-being of rural populations. As we all know and think about, there are many positives to rural life, yet rural populations, which we don't think about, already experience chronic intermittent exposures to all kinds of powerful pesticides and fertilizers, as well as the legacies of oil, gas, and mineral mining, logging operations, and for Iowa in particular, as well as some of our other states, the CAFO-associated waste and water pollution. So for much of the country, water quality violations particularly pervade rural landscapes, even as many of our residents rely on local food and fish for their nutritional intake. So while resources, residents, and risks in rural areas vary across the country, just as they do in urban areas, we live in our rural areas with some significant differences. We are particularly vulnerable to facing and responding to any emergencies. Unlike better provisioned and more closely integrated metropolitan areas, rural populations have to respond to catastrophic events with their hands tied. The challenges to promoting and maintaining the health and well-being of rural populations are compounded by several factors. While 97% of the US landmass is rural, 2/3 of US counties are rural, but only about 20% of our population lives here in relative isolation by definition. So, dwellers face longer distances between neighbors, fewer interactions, and fewer basic resources. A preponderance of rural residents experience poverty and precarious lives. Rural poverty rates are higher across all ages, races, and ethnicities. 21% of rural populations are Black, Indigenous, and people of color, with about 5% of them being new immigrants. And close to 30% of rural children live in poverty. A much higher percentage of rural residents are elderly. We have about 11 million elders, 17 or 18% of the rural population, including especially a high percentage of minority elders living rurally. In urban areas, only about 14% are elders. And it's well known that the more rural the area, the older it is likely to be. And for us here in Iowa, it's amazing, but about 41% of our elders live rurally. And of importance to remember is that elderly residents are likely to be poorer, sicker, more fragile, with chronic conditions presenting, about slides are kind of jumping around. Where was I? So they present a lot of pre-existing health challenges, which are more common, as we've already heard, symptoms also of exposure to elevated levels of CO2. And as Sandra mentioned, there's not a lot of awareness of this kind of conjoint risk of presentation. So some of the concerns that we have in the rural area also include the poorer quality health services. We see many of the country's health professional shortage areas here in rural areas. In particular, the areas that are majority Hispanic, about 81% of them are health professions shortage areas, as are 83% of those of African American majority, and 92% of those with American Indian or Alaska Native majority. So these are areas that are really poorly managed for their healthcare. Similarly, we see real shortages within emergency response teams and management in counties where rural and ethnic minorities are more than half the population. Rural emergency responders are not equipped to handle a CO2 rupture, as we've been told. I'm just underscoring that. First responders are volunteers, themselves widely dispersed across the area. Rural emergency management agencies often lack trained paramedics and advanced trained EMTs. They lack appropriate protective equipment for responders and for those in need of rescue in any potential mass casualty event, much less a rupture of a pipeline. Gaps in services obviously lead to poor health outcomes, and already we see disparities in life expectancy. Next slide. About transportation in rural areas, while we all think they might be lovely places to visit, and while almost 20% of our population lives there, a lot of miles are covered in rural areas. We have very few good roads. In fact, I wrote a whole book about it. Many have been constructed to relatively low standards within the limited budgets of rural counties. They're full of unpaved surfaces, and lots of surprises, which on a good day are kind of entertaining. Livestock crossing, the humongous farm vehicles that kind of lumber along. There are also unmarked driveways and farm entrances. These rough road conditions are especially hazardous, however, in extreme weather, which we are seeing more of all the time. There are really limited options and long distances on these marginal roadways, lack of public transit, longer distances, obvious dependence on ride sharing. All of these make emergency response travel particularly hazardous. And we can't overlook the fact that regardless of how people think they might be safe, they're safer obviously than trucks and trains to transport volatile chemicals. The history of many thousands of miles of pipelines for LNG, petroleum, other toxic substances that crisscross the US includes already tens of thousands of ruptures, large and small, thousands of injuries, hundreds of fatalities. All of these already have led to pollution of surrounding land and waterways, but none of these that we already know about are as hazardous as CO2. Building out CO2 pipelines crisscrossing rural areas puts local communities at great risk. Ruptures along existing pipelines are frightening no matter where, but all the more so when considering transporting deadly, concentrated, odorless, colorless CO2, which can disperse over hundreds of meters to miles, depending on topography, wind, pipeline size, and the extent of the rupture. So in conclusion, in my last slide, I'm just saying the obvious in some ways. Last slide, yeah. Our world needs energy, but it also needs food, it needs clean water, and it needs a healthy population within a livable climate. Effective climate solutions that preserve farmland for food production are critically necessary. Property rights, the just application of eminent domain, the preservation of valuable farmland are not partisan issues. CCS and CCUS will not reduce threats to public health or the climate, but rather perpetuate and exacerbate the production of climate, environment, and health harming conditions already extant in our rural areas. They allow fossil fuel and other CO2 producing industries to continue polluting business while increasing risks to our health and well-being, particularly to vulnerable rural and frontline communities, squander billions in public funds that should be spent on readily deployable renewable energy. Critical climate survival, mitigation, and adaptation strategies are needed, improving regenerative food production and repairing the harms done to the health of people and the planet. Carbon capture deflects public attention from the changes we need to make quickly. We must remember these technologies are largely aspirational, and if by some miracle they could be launched at the scale required to affect the climate, they threaten to make matters worse. As we say in medicine, first, do no harm, avoid replacing one dirty, harmful form of energy with yet another. And with that, I'm going to pass on to our next speaker. Carolyn, you want to introduce Martha?
Thank you, Maureen. And I want to just highlight that carbon capture and storage, when you add use, the CCUS is carbon capture and use and storage. And that is a deflection by industry to say, well, it has beneficial uses. Marta Dina Argüello, longtime friend and colleague, former board member of the Science and Environmental Health Network, and one of the most creative and astute sounding boards for innovative policy I know. Executive Director of Physicians for Social Responsibility in LA. Take it away, Marta.
Thank you so much. So first I want to just say ditto to everything Maureen said. And as she was talking, I'm like, oh, I forgot some slides, but I'm gonna move on anyway. You know, California is considered a climate leader, and I'm embarrassed to say that what we are is actually California is completely captured by the oil industry. And, you know, I'll show you why this matters to the environmental justice community. One, sort of, it really builds on what you've already heard, that we haven't looked at the health issues. And But in California, we have been moving along, next slide, for a number of years. And in fact, there is an active campaign, Last Chance California, which has been pushing first Governor Brown to do real climate leadership, and now on Governor Newsom to actually keep fossil fuels in the ground. And while they have made these noises, what we, next slide, what we continue to see in California is concerted, organized efforts at every level of the regulatory structure, at the legislature, and through various nonprofits and an extensive network of lobby groups that are promoting the use of carbon capture and sequestration. This is some of the threats that you see, and look at the green part of that map. That's where there is potential geographic storage for this. And if and imagine a map that shows you where vulnerable communities are. We have a tool called CalEnviroscreen. I should have added that map, but I didn't, but you can go look at it. That green area is pretty much what is in red in the CalEnviroscreen map, which shows the highest level of exposure and vulnerability. It's about 19 factors. And so they plan to store things where there is already infrastructure, refineries with these little clusters down by Southern California and in Northern California facilities. And so because California is an oil producing state, there is much infrastructure that they feel is very ready for carbon capture to sit on top of or to figure out where to place it. And so it is the cornerstone of California's climate strategy in the next slide, in the scoping plan. So as you can see at the bottom, this is a busy slide. They've got alternatives that the state of California is looking at, and there are the total CCS needs. So it's a foregone conclusion that the scoping plan will include carbon capture and sequestration. They are very nervous because there has been extensive resistance, but it is still in the plan. Next slide. And this is what I sort of feel like every day. It just hits the space bar. And the next part of the slide will come in. So these are the sets of policies that are together really creating quite a set of challenges and threats to the environmental justice community through in terms of how California is focusing their climate policies. Next slide. So this is what the threats look like. As Maureen talked about, everywhere where there is pipeline, that is being looked at as potential sites, right? So it is being built on top of the existing oil infrastructure, and we should not be confused. It is to be able to continue to extend the life of fossil fuels throughout this intersection. And why this is an environmental justice community issue is communities live in these communities. These are the same communities who've borne the brunt of the fossil fuel industry up until now. And the idea that we would find ways to extend the life because next slide. And again, the low carbon fuel standard is also deeply connected. And what we missed, because it wasn't done in the most transparent way, is that California has been moving with the CCS protocol since 2018. So it's not new, but it's one of these threats because environmental justice communities live with multiple threats every day. And when we are engaged, we have been working really hard to keep fossil fuel in the ground and, realizing that there is a plan for our communities. Next slide. Next slide. So this is what is happening at the state level, and I'm moving fast because I know I've only got 10 minutes. So there is at least 5 that we know of now, pro-CCS bills, everything from defining CCS, defining how much we should capture from cement. And then there's the guardrails bill that was also a pro-CCS bill, but we managed to stop it last year. And now people are like, well, what guardrails do you want? And, in a conversation the other day with the head of Cali PA, I said, I want you to be clear. We would like for this not to happen. And the only reason there's a conversation about guardrails is you seem bound and determined to do this no matter what anybody says or whatever other evidence we bring to you. And and that is what it feels like. And then there is one bill that we've been working with Senator Limon that would limit carbon capture and direct air capture and using it for enhanced oil recovery. Next slide. There are already plans on the ground and communities in that Central Valley where you saw that yellow part where they're going to do the capturing and the storing. There is already permits that are being pulled. This is one plant. It's a BEX plant in Mendota. To add insult to injury, these are the folks that are working on this are with the Center for Race, Poverty, and the Environment and the Central Valley Air Quality Coalition. It's a growing number of groups who are engaging on this because the permits are happening. This facility was closed through community advocacy, and now it's being re-permitted as a BEX facility. So the threats are multiple and extensive. Next slide. This is what the plans are for geologic storage in the Delta. And again, the first on the ground were the lobbyists, and then we knew that things were happening. And so we've been hearing, we heard a presentation from Lawrence Livermore Labs. They are fully in. They are doing opinion studies to see how they can convince the public about this. And so this idea of informed prior consent is incredibly important for communities. Next slide. So this is a really busy slide, but I reduce it to, don't piss on my head and tell me it's raining, right? Because there is a lot of policies in California, but none of them are actually designed to keep fossil fuels in the ground long-term. And then to tell us that what CCS requires is a strict regulation, oh, don't worry, we'll be able to store it. It is, a slap in the face to the environmental justice community because we live every day with profound regulatory failure. Storage facilities leak. Agencies are captured by the polluters and so are not doing the best, so this myth of that we can regulate it and we just, tighten it up is a myth, because if it weren't a myth, there would not be so many environmental justice communities who are underprotected and overexposed. So next slide. And the things, I will say, folks who also say, we don't do well with long-term storage, right? It will require 100 years of regulation and storage. We just don't do well. We also know that in California, we have many refineries and that the possibilities for this practice to happen in California is pretty extensive, right? You see all those black dots, those are all parts of the refineries. And now we're already seeing refineries switch to biofuels production. Then we're trying to now understand where hydrogen fits within this whole sort of scheme to perpetuate the fossil fuel industry. Next slide. Breathing. So how do you stop a moving train? Because that is what this feels like, an incredibly well-funded moving train. Our communities are at the same time grasping to understand what the technology means, trying to grasp the political moment that we're in, and how do we actually create a wave of resistance to actually keep fossil fuels in the ground, do what Maureen said in terms of restorative practices, thinking about what a just transition looks like and rethinking what work looks like, because there are drivers within labor who want this to happen, because we're used to big projects, big giant, construction projects. So there is the way to organize around this is really what we're doing here, is making sure communities understand the science, make sure that people are hearing what no one is talking about and what are the potential threats and pitfalls, and then really mobilizing around, having a strong stance that our communities can't continue to be sacrifice zones. Next slide. So I want to go through these really quickly because I have a minute, but keep going. Next slide. All of this is about turning carbon into a commodity. It is commodifying carbon, allowing it to be bought, sold, and used to recover more oil. And that to me is, an essential violation of many of the principles of environmental justice in terms of how we live with the world and that what we actually need as part of the solution is to move away from this commodification of things in this way, right? No one owns the sky. You shouldn't be able to buy and sell credits to pollute the sky, and you shouldn't be able to continue to pull out oil at the same time that you're saying you support you support climate policy. Be clear, be clear. Carbon capture is designed to produce more oil. That is it, right? It is designed so that business as usual is maintained. We should not be fooled by sort of the promise of it. Next slide. These are some of the companies, not all of them. And next slide. This is some of them, and also not all of them, some of the nonprofits who are supporting CCS. Next slide. These are some of the funding, the research institutions. Again, not all of them, just a few that are being funded to promote CCS. Next slide. And then labor unions. And next slide. And if you get a chance, if you can click on, I know I got like 3 minutes, like less than a minute left, but this is actually really interesting because it speaks to, we want to speak to the science, but we need to speak to the power. And this is a map of the influencers who are promoting CCS. It's both companies, and if you can't open the link, it's really hard to see, but the link is there. And what's interesting in California is this revolving door of regulators moving from the regulatory agencies. One who was the general counsel at CARB is now the chief lobbyist for the Carbon Capture Coalition. And so it is important to call those things out. As important as the science, it's important to talk about who and why this is being moved. And for the health community and the environmental justice community to be clear, this is a false solution. And I joke that I feel like I'm on a loop of the Don't Look Up film. And this carbon capture and sequestration is the idea of going and mining the asteroid, right? Versus doing all the things that we know will actually make us healthier and a more sustainable and just world, right? So with that, I'll stop. Thank you so much.
Thank you, Marta, Dina. I want to invite our panelists to start looking at the questions. There are some that are targeting that Marta, Dina, we're going to ask you to answer, Ted, and so forth. So if you can look and bookmark the questions that you will answer, that would be great. And now I'm going to turn it over to Arjun Makhijani, who is the president for the Institute for Energy and Environmental Research, talking about the opportunity costs for CCS. And Arjun, I haven't seen you in probably 20 years. So it's a great honor to welcome you to this conversation and presentation. So take it away.
Well, I'm balder since you last saw me.
Yes.
Okay. I'm not going to talk about, so you've heard a lot about the health. I've been doing research for the Just Solutions Collective, which was set up just over a year ago, on CCS, on some of the technical and financial economic aspects of CCS. If it works, what will it cost? And so what are the opportunity costs? So this work is currently going on. So this is a partial account of the work that I feel comfortable talking about in public. Next slide. So how much CO2 are we talking about? This is a very elementary thing that people should know. So we've got about 418 parts per million. 1 part per million of CO2 in the atmosphere has a mass of almost 8 billion tons, 7.8 billion metric tons. So 1 part per million is a lot of CO2. We're adding net to the atmosphere about 2.3 parts per million since 2005. That's NASA data. There are some links in the bottom of my slides that you'll probably be able to get. So every year we're adding about 18 billion metric tons to the atmosphere. That's not the emissions, which are greater. Some of it goes into the ocean, for example. You've heard about acidification and carbonic acid. And so there are also in the chat, there's been some stuff about, what are we going to do about cement and so on. Difficult questions that we should acknowledge. Steel, aircraft, maybe 15% of CO2 emissions, rough numbers. So there is an issue of mitigation that we should address. Now, I'm not going to address it in my talk because it's 10 minutes about CCS in a couple of restricted sectors. So what's the scope of my talk? Next slide, please. So I'm going to talk about air capture and sequestration, something that Breakthrough Energy, a prominent venture institution doing research funded by, partly at least by Bill Gates, is doing. Point source capture, which you've heard, most of the talks have been about point source capture at an ethanol plant or fermentation plant or a power plant. And so I'm going to talk about that. I'm only going to cover these mechanical chemical approaches. I'm not covering, so when you take out CO2 out of the atmosphere, the ocean is going to outgas some if the CO2 concentration actually goes down. So I'm not going to cover that. I'm not covering use. I'm not covering soil carbon sequestration or biological approaches. I'm not covering biomass energy followed by CCS. Not covering non-CO2 greenhouse gases. All those are issues that deserve to be covered, but I'm not going to do that today. I'm just going to give you a couple of few stark numbers that are relevant to today's conference. Next slide. So the target for air capture is $100 per metric ton or less by 2050. Today, the cost, according to Bill Gates financing the energy revolution, I think his paper is called, the current cost is $425. There are other estimates that are higher, $500, $600 a metric ton to capture CO2 from the air. So to capture 1 year of CO2 increments, that is to keep CO2 in the atmosphere steady at this $425 a metric ton would be about $8 trillion. That's a non-negligible fraction of the global GDP, about 40% of the US GDP. At $100 a metric ton, you're still talking $2 trillion a year. So these are numbers that you can't actually hold CO2 steady in the atmosphere by simply doing air capture, burning coal and then going back and saying, I can get it back from the air. And that doesn't include sequestration costs. That's a big question mark. I've been surprised actually that estimates run from less than $1 a ton to over $1,000 a ton. So that's more than three orders of magnitude. Common estimates are $20, $30, $40 in that range, sometimes $10. Round numbers, if you do really well and reduce the cost, so I'm not talking about all the difficulties and the health problems and so on, right? That's been covered. If you do really well and you're trying to address much or most of the difficult sectors and remove 10% of the annual CO2 increment at $125 a metric ton, you're talking $250 billion a year if you're going to go air capture. That's after you reduce the costs. Currently, it's very high. So if you start now and go to 2050 at $400 or $500 and wind up at $100 30 years from now, your average cost is going to be a lot more. Okay, so these are gross costs and gross capture. So as you might imagine, it takes a lot of energy to capture CO2 from the air. It's only 0.04%. So you got to handle a lot of air and a lot of chemicals in order to extract that 1 ton. If you do it with the present energy system, you're going to emit a lot of CO2. You're going to burn natural gas. You're going to, use a lot of electricity and so on. So I am actually researching this. I can tell you that you are going to use a lot of energy and you're going to emit CO2, and the net CO2 capture for all that money is going to be a good bit less than a ton. I'm not done with the research yet. So the other side of that coin is, even if you get down $100 per metric ton, if you're using it in an energy system that's something like today, the actual cost is going to be a lot more than that because you're only capturing net a fraction. So in order to do it right, you actually have to have a completely decarbonized or nearly completely decarbonized energy system. And by then it'll be, I think, if we wait for this to save us, it's not going to be in time, in my opinion. So very costly, very difficult, and net yield is not promising. I'm trying to use British understatement as much as I can. Next slide. Okay, so I was asked to talk about opportunity costs. So remember, there's $100 billion per year pledge to the global south in the Paris Agreement. The Western countries are not delivering, and what they count isn't actually material. Much of it, I don't think, is good money. If you had $250 billion a year, you could fulfill that $100 billion a year pledge as grants. I do think that fulfilling that pledge will bring the global south to actually accept a timetable of 2050 to get rid of CO2 emissions as much as possible. How much is possible is another talk. So Maureen can say more about this, but I think $100 billion a year would go a long way to integrate what the World Health Organization calls the forgotten 2.6 billion people who now cook with kerosene, wood, cow dung, crop residues, and so on. You're talking billions of tons of biomass and coal also. Cooking with coal in rural areas in certain parts of the world, quite common. Nearly 4 million lives are lost each year, mainly women and children. That's the sort of one health point I'm going to join with. And Maureen actually knows a lot more about this than I do, although I have worked in India's villages and seen firsthand and read by kerosene wick lamps. And lighting with kerosene, very common, big health hazards, safety hazards. 50 billion a year, I would say you could use it for just transition for fossil fuel workers. Worldwide, remember, it's not just the United States. People forget often operationally that climate is a global problem. You cannot solve it by solving US problems. As a reminder, US is about 15% of greenhouse gas emissions. So, if, the European Union may be comparable. So put together, you're still talking only a third, roughly speaking. So if you don't attend to the rest of the world, we're not going to solve the climate problem, guaranteed. So that 100 billion is important. So you can save 150 billion and fulfill that pledge as a grant, 100 billion a year. We have a much better chance of fulfilling the 1.5 limit. It's going to be extremely hard. Next slide. So what about point source capture? You heard mostly about this. As you heard, I learned a lot today. Thank you all very much. Uses chemicals, fossil fuels to do the job. So you have greater ecological damage. The literature on this is unequivocal. More eutrophication, more mercury, more NOx, more tropospheric ozone, more coal ash, more toxic fly ash, more coal per unit of delivered power. The list is actually longer. And you can mitigate some of these things, but you can't eliminate the greater ecological damage, and mitigating them, of course, is going to either take new coal-fired power plants with new technology, which would increase the cost greatly, and perpetuate coal even longer. And you're not talking 100% removal from the flue gases. If you're lucky, you're talking 90%, and then you've got all that energy to pump and store and all that. So even after all that, if you go on using fossil fuels, you're going to have net emissions where you don't need to have net emissions. Cost, currently estimated by the Congressional Research Service publication just from a few months ago, $43 to $65 a metric ton. Industry says it'll come down, but they've been saying it's like, nuclear fusion, it's always far away and lots of money being poured into it. I haven't seen the cost estimates of this come down over the years that I have looked at this off and on. This is not my primary area of study, but I'm paying much more attention to it now because of this current situation. So coal-fired power would cost about $80 to $100 a megawatt hour from existing mostly depreciated plants per delivered megawatt hour. We use, a typical largish house would use about a megawatt hour a month. So that's what we're talking. That's wholesale at the power plant, plus transmission distribution. This, assuming it works, repositories can be cited, developed, and you can seal it. And that's a whole different subject in itself. I'm not going to talk about it. I haven't seen evidence that industry hopes for cost reductions. It's sort of more or less like the other thing that's being promoted, the nuclear industry. They keep talking about cost reductions while the costs are always going up. Here, the estimates have held steady because nothing much has actually been done other than enhanced oil recovery, where the cost is absorbed in the cost of oil production. So as a point of comparison, new solar and wind utility scale are $40 a megawatt hour. But it is important to note that people talk about comparisons between wind and solar and nuclear. It's not entirely, it is right at one level and not entirely right at another level. You do have to fit wind and solar into a very different grid. So I took several years to do the math about that. And my conclusion, quite firm, from 6 years ago now, in a report I did with hour-by-hour modeling for the state of Maryland as a kind of autarkic energy system for simplicity, is that solar, wind, storage, demand response, smart grid, being sensible about the energy transition, not the way most models do it, would cost considerably less than business as usual. So I can say this with, now it's been 6 years, I've been around listening to a lot of people talk about their models, looking at the cost evolution of solar, wind, storage, demand response, smart grids, electric vehicles, all that, heat pumps. I am utterly confident that going to a solar and wind-based, reliable, resilient energy system will be cheaper than business as usual and cheaper than going the route of fitting CCS and nuclear into the existing. I think that's it.
Thank you so much, Arjun. We're going to open it up for just a few minutes of questions. Ted, I'm going to give the first question to you. There's a question that was posed that the question was, wasn't Satartia actually less dangerous because they had hydrogen sulfide in the mix of CO2, which alerted the participants that there was danger? Can you speak to the situation at Satartia regarding the CO2 and hydrogen sulfide?
Yeah, that was a pipeline that was carrying a mixture of CO2 and hydrogen sulfide. It's a mixture of gases that was being shipped for use for enhanced oil recovery. Hydrogen sulfide is much more toxic at lower concentrations than carbon dioxide is, but hydrogen sulfide also has a rotten egg smell that alerts somebody that they're being exposed to a toxic gas. So I would agree with the question that everybody that was interviewed that was in that area reported smelling the toxic or the rotten egg smell. So they knew something was wrong. From a purely medical point of view, it's going to be hard to separate out how much of the symptoms were due to the CO2 and how much was due to the hydrogen sulfide. But there's no question that the hydrogen sulfide alerted people, and at least some people were able to avoid prolonged exposures.
Thank you. I'm curious, Marta, if you've specifically looked at the geologic storage issues, CO2 and earthquake fault lines. What do you see in terms of the danger that earthquakes pose to all the CCS schemes?
I think we were all apoplectic on that call with the Lawrence Livermore, because I have grown up in LA and I'm like, if this was true around hydraulic fracturing, it's true now. And they did not answer that question when folks asked. So it does worry me. And frankly, I have not done more research on this. And I'm looking for, we are still catching up on the science of some of this.
Yes, it's if for those of you who are interested, especially in some of the federal work, by the way, the Center for International Environmental Law and Food and Water Watch both have extensive materials in addition to the Science and Environmental Health Network and PSR. But CL and Food and Water Watch are doing quite a bit of work with DOE, with federal legislation, and you can check their websites for that and stay tuned. You can also get more information at a website that has lots of information that the Science and Environmental Health Network is sponsoring with many organizations, and that's carboncapturefacts.org. So you'll get quite a bit of more information, and we will share all this with you if you've registered for this particular webinar.
Carolyn, can I just make one remark in addition to Ted's regard, or in addition to Martha's in regard to the risk of pipelines from natural events? Here in Iowa, where we do have pipeline ruptures, not only because we have unstable land, but because we have farmers with big equipment digging into the ground to tile the land. And emergency response people know this, that the pipelines can be ruptured quite unintentionally by our farmers just doing their business. And I don't think, as I mentioned, that they're at all prepared for what the real catastrophe would be if those particular pipelines began to be dug up by our farmers intentionally or otherwise. So if these risks are there for everybody.
And it turns out that insurance companies are now telling farmers in the Midwest that they are not likely to cover them in the case of the kind of disaster that Maureen just described. So if a farmer accidentally hits a CO2 pipeline or causes an accident through whatever is going on their land, that may not be covered by insurance. The mental health stresses of these could be something that we'll have to have a separate webinar on. Are there other questions that you've seen that you would like to address in this? Martha, there are some questions. Yeah.
Yes, well, I've answered, I think the question about, and we're hearing this, but what about for these hard to decarbonize sectors like cement, jet fuel, and others, right? On the jet fuel, we're hearing it both in the CCS context and in the hydrogen context. We're, we haven't known how to answer them well, I think. He said, like, just me, I have it, and PSR-LA.
There was another question about other uses for CO2, especially coming from the Midwest. And that was around, it's used in pop, it's used in, couldn't there be other uses for all the CO2 than sequestering it or enhanced oil recovery? Does anyone want to cover that question?
Could I go back to what Martha just said, if you don't mind?
Sure.
Yeah, I think it really is very important for us. I actually didn't show my last slide, I realized, to accept that there are difficult sectors, to come up with answers that are credible, because I don't think the establishment is going to come up with the answers, because the establishment has given us the answers, nuclear energy, CCS, all of that. That's the establishment answer. We think it's not good, but that doesn't solve the problem. It's like saying nuclear energy is 64/7, low carbon, so you don't like it, then what's your answer? How are you going to make solar and wind reliable? That's for us to say, and I've tried to say that. So I think it's very important to understand, and I think everybody in this company understands, that at 1.1C, we're already in deep, deep trouble, and we're going to continue to burn carbon for some time. The IPCC budget is 400 billion tons. They say we've got a remaining budget. I'm skeptical, but that's 400 billion tons more. And there's all the other gases. So we do have a very big mountain to climb, and soon. And that's why I said continuing research. I'm not going to give you the answers today, but I am worried. I have worried about this particular problem for 30 years, and now I'm really pretty much focused on it for much of my time, other than nuclear weapons. The other problem. Okay, sorry about.
Thank you, Arjun. Ted, do you want to answer the question about can't this CO2 be used in other things?
It can be, but then what happens to it? So I saw in the chat, in the questions, for example, using it for dry ice. That's a solid form of CO2, but it sublimates into CO2 gas. So it won't stay as solid ice forever. It will sublimate, and the CO2 will be reduced. If you put it into fuels, you're going to burn it. You're going to end up releasing CO2 at the other end. So you have to think through the whole life cycle of this.
Thank you.
The sequestration approach is intended to say this is a way we can put it away forever. That's the promise. But as has been pointed out, this really hasn't turned out to be the case in many places where it's been tried.
Barb, I'm going to turn it back to you for the wrap up.
Thank you, Carolyn, and thank you to all of our speakers. This has been really fascinating, and I know I have learned so much. We have only a few minutes left, and I'm going to ask our speakers to do something that's almost impossible. Let's acknowledge it, but we're going to give it a try. I'd like to ask each one of you to give us 3 bullet points that represent, say, 3 major ideas that you want our audience to walk away with. Just 3 bullet points, really, really brief, because then I would like, and I think perhaps this is the most important, I'd like each of you to state 1 major ask. What action, what next step would you like folks who are here today with us or watching this, watching the recording in the future, what is 1 next step you'd like folks to carry out to put into service what we have learned today? So I'm going to call on our speakers in the order in which you spoke. And again, 3 summary bullet points, or 2, if that'll work for you, just really brief, and then a major action. So Dr. Schettler, can we put you on the spot and you go?
Okay, let me give it a try. I'm going to take my lead from UN Secretary General Antonio Guterres, who said after the latest IPCC report was released very recently, he said, and I quote, "Investing in new fossil fuel infrastructure is moral and economic madness." I think that that's my sentiment in a nutshell. I think that the CCS projects become feasible only with state and federal subsidies, and that we should be putting our resources and subsidies toward promoting energy efficiencies and further development of renewables. And I think it's in that latter that I would encourage people to think about where they might take action to do that, rather than being distracted by this CCS approach, is to think about how we could do put our efforts toward renewables and some of the things that Arjun talked about. So I'll stop there.
Great, thank you very much. Pardon the dog barking in the background, it has to happen, right? Dr. Steingraber, can you go next? And again, just maybe 1 or 2 really salient ideas and then an action suggestion.
Okay, I'm actually going to try to peg these to the questions that we heard. So I point out in my in number 1 that the models that show how we could get to net carbon zero by 2050 would necessitate 66,000 miles of carbon dioxide pipelines, including more than 13,000 miles of interstate lines and thousands of deep earth burial sites. This is according to a study from Princeton University. Okay, all of those pipelines, that's way more lines than we even have to ferry oil and gas across our country. All of those pipelines are bisecting communities where people live. And presenting health risks to them, acute health and safety risks to them for all the reasons that we've heard. That's just wrong. Those communities are disproportionately represented by poor rural white communities, indigenous communities, and Black and brown communities. So this is carbon capture and storage is an environmental justice problem. So that's point number one. The second point is about earthquakes. So when we've put the carbon under the ground, and we actually talk quite a lot about the earthquake risk in the forthcoming compendium. And what we know about the earthquake risks from carbon capture actually comes a lot from the literature on storing fracking waste underground. And so we can use those same models to make some good predictions. And in fact, there are increased risks for earthquakes that could compromise the seal integrity of the repositories large enough to sort of breach the seals. And then, in other words, not only are there risks to the people who live near the pipelines, but there are possibly acute risks from sudden bursts of carbon dioxide, which would vaporize coming out of the ground in places where it's buried, because we could induce earthquakes. Even if we don't induce them, naturally occurring earthquakes could also breach the seals and release CO2. So in other words, there is an environmental justice problem also in the communities underneath of which the CO2 is going to be buried. And then thirdly is always to remind us that the primary use of carbon capture and storage is to enhance oil extraction. Of all but one of the 12 CCS projects in the United States uses captured carbon for enhanced oil recovery. So in other words, CCS functions as a fossil fuel subsidy. It entrenches fossil fuel demands, and it impedes the phase out of fossil fuels. It's a backwards thing. So my ask is like, comes right out of the golden rule. It's still wrong to kill people. It's still wrong to threaten people. This is not a solution. So even if we don't know how to do cement or do jet fuel yet, this is clearly not the way to do it. That's it.
Thank you. Dr. McCue?
Well, I guess I just have to repeat what people have already been saying. One, CCUS is a diversion, a false promise. Real solutions can't come at the cost of more health and environmental destruction. Health professionals and others must hold elected officials, financial institutions, and our own healthcare institutions, our academic institutions to account. We know climate change is a medical and a survival emergency, and health professionals and other academics can do more than offer advice to help them protect themselves from environmental risks. They have to be compelled by public, by their patients, by their colleagues to act together as a powerful social conscience and persuade our leadership to take action to protect our health by ending this preventable pollution idea and unnecessarily risky initiative. Call for emergency action to limit all of this.
Thank you. Ms. Argüello?
Oh God, you know what? Resist the temptation, especially those of us who are in the sciences, this idea of that a solution, that there will be a technical fix to what is essentially our mismanagement of the economy of our planet and our health. And so this idea, throw it, it's an emergency, throw things, stop thinking that way. The real emergency is our lack of justice, and that we are willing to say, oh, I know that solution is gonna make your community worse, but it's an emergency. Stop asking people to make that sacrifice, and then invest in other solutions and in real imagination. And at the end of the day, what, you know, right now, I feel like we need to focus on resiliency and how, because our communities are already feeling the effects deeply. And so support work around a resilience, it is as important as throwing every tech solution that sticks and see what we can. And then fight like hell to stop this subsidies going to the fossil fuel industry, fight like hell against false solutions. And I love what Sandra said, because that is what gets thrown at us. But this thing, but that thing. Well, you know what, let's do all the things that we know are ecologically based and sound and restore communities and restore justice and let justice be the guiding light for what we choose. And then we can figure out the others, as long as we are also embedding the idea that we need to protect communities who are already living with the harm.
Great, thank you.
And then, yeah.
Thank you. Dr. Makhijani, I know it's hard with so many wonderful things that have been said. Maybe since we have only one more minute, if you could focus on what you see as really the most important action that our audience members can take.
Well, I want to say two things. I think operationally in the West, United States, North America, and Europe, there's a lot of talk about climate being a global problem, but no practical political recognition, even among environmentalists, that it is a global problem. The specific I would say is there's no practical demand for that 100 billion to show up every year. And it's been 7 years since the Paris Agreement, and some considerable amount of CO2. So I think, in other words, Europe lives on planet Europe. United States lives on planet America, but this is not a problem that can be solved on planet Europe or planet America. Absolutely not. It cannot. So that's my message, is that if we want this problem to be solved, we have to live on planet Earth. And we've got that message in other ways, but not in this way. The other thing I'll say is I've been involved in energy since 1970. And my first involvement was on efficiency. We made a lot of progress on thinking about energy efficiency, how to do more with less, and so on. We haven't done the same with materials. It's at least as big a problem. And I was happy to see, I've just begun scanning the most recent IPCC report that came out. So a few thousand pages, like all of them. But I was happy to see that it does have the materials problem mentioned explicitly for the first time. If we don't, and the materials problem, as somebody said in the chat, affects wind turbines, it affects nuclear power plants. It's common to all our activities, buildings, power plants, you name it, and we absolutely have to put it on the radar. So those are my two points.
Thank you. I'm afraid we'll have to leave it there. We're about out of time. Clearly, the challenges facing us are great. Thank you to all of our wonderful speakers today, and thanks to all of you who joined us on behalf of PSR and SEHN. Thank you and goodbye.